So the first topic for this class is units and unit conversion. And the idea of units is, so first of all, every physics measurement needs to be associated with units. Like, for example, if someone asks, how close is your phone? And you say 6 or whatever, that doesn't tell anyone anything. If it's 6 inches, then it's really convenient. If it's 6 miles, it's not very convenient. They'll just find someone else's phone, So those units are an important part of that calculation. All the units that we're going to use in physics, well, in this class at least, there are a couple more types that we're not going to use, but all units in this class will be combinations of 3 basic types. Units of length, so examples of that are inches, feet, meters, miles, so on. Units of time, so examples of that are seconds, minutes, hours, and units of mass. And examples of that are grams, kilograms, the imperial unit slugs. It's harder for me to think of good examples for mass. And the ones that are going to be most important for us for doing calculations are meters, seconds, and kilograms. Any units made of those 3, so made up of meters, seconds, and kilograms, are called SI units, Standard International. And those are the ones we're going to use by far the most in this class. But one thing that's going to happen a lot is we're going to be given measurements, Oh, yes. What? This probably not. Maybe late in the semester, possibly, but not for a while at least. A lot of times we're going to do physics calculations based on measurements that someone gives to us. We're not going to take all the measurements ourselves. And if someone else gives measurements to us, we can't control what units they're using. And so it's going to be pretty common that we're going to want to convert from, say, 1 unit of length measurement to a different unit of length measurement. If we want to use meters and someone gives us a length in miles, we need to know how to go between those two. So often, we'll want to convert a measurement from one unit to another of the same type. Okay, so for example, you know, in simple cases, I mean, a lot of you have taken chemistry and you've done all the unit conversion you need, but for the rest of you, I guess, even in your everyday life, you're somewhat used to this unit conversion idea. An example would be, you know, how many inches are there in 3.5 feet? So what I want to do is, you know, that's sort of a simple case, and that's one that you could probably figure out just without really a formal method. But I want to come up with a method that's going to work in these simple cases, but it's also going to work in complicated cases when our units start to be things like kilogram, meters per second squared. Yeah, you know, there's units everywhere. That one isn't so obvious how to convert from that to a similar, to the same, you know, another unit of the same type. So here's the approach that we're going to take. Okay, so there's between two units of the same type, there's always going to be a conversion factor that you're going to have access to. So 2 units of the same type always have a conversion. So in the example I gave above, we know that 12 inches is equal to 1 foot. And that produces 2, what I'm going to call conversion factors. Both of those are just 1 divided by the other one. So the 2 are 12 inches over 1 foot. And 1 foot over 12 inches. And notice, since 1 foot and 12 inches are really the same thing physically, we can think of both of those as, you know, you're dividing one thing by itself. You can think of them as both equal to 1. In other words, you can multiply anything by either one of these without changing the overall value of what you're multiplying it to. And so now what we're going to do is we're going to take our original quantity and multiply it by one of these conversion factors. So multiply our original quantity, that's an abbreviation, by a conversion factor. Okay, so in our example, we started out with this quantity 3.5 feet. And I'm going to multiply that by 12 inches over 1 foot. And you can think of those units as just algebraic variables. They obey all the same arithmetic rules. So the feet here cancel the feet here. The only units you have left are inches. And the number that's left is what you get from multiplying 3.5 times 12 divided by 1. And so you get 42 inches, and that's the answer. There's one thing you have to be careful of, though, and that's that only worked because I just happened to choose the right one of these two conversion factors. Look what would happen if I chose the other conversion factor. So we have 3.5 feet. What if I had multiplied by 1 foot over 12 inches? Now the feet don't cancel, and if we multiply that out, we get the number 0.2916 repeating, and the units are feet times feet over inches, or feet squared over inches. Okay, well, it turns out, there's nothing wrong about this equation. Is not incorrect. 3.5 feet is equal to this many feet squared over inches, and that is a unit of length that you could use. It just isn't the one that we wanted. Okay. So we need a strategy for always choosing the right conversion factor for the units that we want. And so the rule we're going to use is, notice, you want to always multiply by the conversion factor that cancels the unwanted units. Okay, so if you go back to, original quantity was 3.5 feet. The unwanted units, the ones we're trying to get rid of, are feet. And so you want the conversion factor. If you're trying to cancel feet that are in the numerator, you need to choose the one of these that has feet in the denominator so those cancel out. Okay? That's why this is the one that we want. And this one doesn't work because if you use the conversion factor that has feet in the numerator, these just multiply, they don't cancel. I'll do a bunch of examples. I want to show you a shorthand that I'm going to use. So when I say 3.5 feet multiplied by 12 inches over 1 foot, I'm going to write that like this. I'm just going to give one fraction bar for the whole thing. Anything that's in the numerator of the fraction goes on top. And the ends of the parentheses, I'm going to give just with a vertical line. Okay, just save a few pen strokes. Any questions yet? Okay. So here's another example. Let's say we want to express 61 miles per hour. And by the way, that's 61 miles divided by hours in meters per second. So these are measurements of speed or velocity. Meters per second is the SI unit for speed or velocity. So we're going to start out with that original quantity. I'm going to put the fraction bar like that. I'm going to start out with 61 with the miles on top and the hours on the bottom. And we need some conversion factors. I'm going to write it here so people who read this later think I didn't forget it. So given that 1 mile is equal to, anybody run track in high school? What is this about? 1,600 about. Not exactly. So if you ran the mile in high school, you were actually a little over 9 meters short. It's 1609.344 meters. And then 1 hour is equal to 3,600 seconds. There was a guy, it's a long time ago now, but let's see, I'd say 2008 maybe, a high school runner at Burnsville who ran he has the Minnesota state record. He ran the 1,600 meter in 3:59. He would have been the 4th American high school student in history to run a 4-minute mile, except when you add the amount of time that it would take at that speed to run the extra 9 meters, it comes out to like 4 flat 0.8 or something. And so okay, so we'll start out with 61 miles per hour. And then we can do it all in the same line. We're going to multiply by one conversion factor that takes us from miles to meters. And then we'll do another one that takes us from hours to seconds. All right, so we're going to go from miles to meters. We're going to either multiply by 1 mile over 1,600 meters, or we're going to multiply by 1,600 meters over 1 mile. Which one do we want? We want the miles of our conversion factor to be in the denominator to cancel out the miles in the numerator from our starting thing. So we have 1,609.344 meters over 1 mile. And then notice that if we just left it like this, I'm going to cancel these miles with these miles. Now we have our length units or meters like we want. It's just the hours we haven't adjusted yet. So we would, if we multiply these numbers out, we have the answer in meters per hour. Now we want to convert the hours to seconds. So we're going to either multiply by 1 hour over 3,600 seconds or 3,600 seconds over 1 hour. Which one of those do we want? We want the hours in the numerator this time because we needed to cancel the hours that start out in the denominator. So we have 1 hour over 3,600 seconds. And now those cancel. And the units we have left are meters divided by seconds, just like we want. And the answer to that is 27.26 meters per second. Any questions about that? Right. Okay, that's a good point. I was so let's do that. What if I didn't give you what if you only knew that 1 hour is 60 minutes? This is what you're talking about, right? Yeah. And 1 minute is 60 seconds. Well, you could just do it. It would just add one more step to this process. You'd have 61 miles per hour. You'd convert the miles the same way we did before. So 1609.344 meters is 1 mile. Then you know that 1 hour is 60 minutes. Yep. No, I'm not. I'm sort of going to ignore significant figures. I'm going to leave that to the chemistry teachers. They love talking about that stuff. So you can sort of round as much as you want. If you do the steps right and then round at the end to that, I guess that's all right with me. Okay, so what I've done now is, so I converted from miles to meters, and I converted from hours to minutes, but now we still need one more step that converts from minutes to seconds. We know that 1 minute is equal to 60 seconds, and so the minutes cancel. And so we have one more step in this conversion compared to this one. But if you multiply all those numbers out, you get the same answer. Yep. Yeah, I'll give you every conversion. Okay, and then there's one more type that you need to be ready for. So I'm going to do an example where I convert 38,640 yards per minute squared to meters per second squared. Express it in meters per second squared. And we're going to use the fact that 1 yard is equal to 3 feet. 1 meter is equal to 3.281 feet. And they'll always be given, yeah. And I mean, on the homework, they might not always be. You just have to Google it, I guess, if it's not given. You know, look up a conversion, like how many, you can look up how many feet in a meter or something. I know there on the assignment there is like a section that gives you a bunch of conversions at the end, but there might be a couple you have to look up. I can't remember. But on tests, I'll always give everything. And then 1 minute is 60 seconds. Okay. Well, it's given in yards. If I would have given you a conversion straight from yards to meters, then that would have been fine. But I didn't give you that, so we're going to have to do it in 2 steps. Okay, so our starting value is 38,640 yards. And then it's per minute squared. And so the way I'm going to do this is I'm going to write this as minutes times minutes. And first I'm going to, so the flow of what I'm going to do is I'm going to go from yards to feet, then feet to meters, and then minutes to seconds. So to go from yards to feet, to cancel the yards in the numerator of our starting value, we want the yards in the denominator of the conversion factor. And now we want to go from feet to meters. So 3.281 feet is equal to 1 meter. And if you cancel these things out, you see yards goes away, feet goes away. And our units of length are meters, like we want. So now we have to deal with the minutes. 1 minute is equal to 60 seconds. The minutes in the starting value are in the denominator, so I want to put them in the numerator of the conversion. So we have 1 minute is equal to 60 seconds. And if I do this cancellation, we can see that I'm not all the way converted yet, because here we have minutes times minutes. We've only canceled one of those. So we're going to have to do this one more time again to cancel the other minute. So again, the one we want to cancel is in the denominator. So we want to put one in the numerator. Is that for me? Oh, okay. Oh. Okay, so the last cancellation, minutes. And now we have length units of meters, time units of seconds, and if you multiply and divide out all these numbers, you get 9.81 meters per second squared. Anyway, that's a number that's a value that's gonna come up all the time. Anyone happen to know what 9.81 meters per second squared is? Yeah, so if something's in free fall, that's the acceleration that gravity is causing, if the air resistance is negligible. Okay, so let's do another one, and I want you to see if you can sort of think through this one. Okay, so let's say that we have a big block, a big cube, where the length of every side is 1 meter. And we want to know how many little 1 centimeter cubes would fit inside this box. So, like, you know what I mean? So this big box that's a meter in every dimension off the table is this high. And we're talking about little cubes this big. How many of those would we have to put inside to fill the big one? Centimeters, yeah. So one, and we're going to use the fact that 1 meter is 100 centimeters. At first glance, it's not real obvious that this is a conversion problem, but it really is. The volume of this big box is 1 cubic meter, and the volume of these little ones are cubic centimeters. So we want to take, we want a starting value of 1 cubic meter, and we want to convert to cubic centimeters. Okay. So see if you can work through that. Just take a couple minutes, talk to the people next to you if you get confused on something. And then I'll go through it at the end. But see if you can convert 1 cubic meter to cubic centimeters. I can't think of a way to do it without starting with the volume. I think you just need to start with that volume. Okay, if you can think of another way to do it and it gets the same answer, it probably works. But I can talk to you about it after. Okay, so our starting value is 1 cubic meter. And I'm going to think about that as 1 meter times meter times meter. And there's 100 centimeters in a meter. So I'm going to do 1 meter is equal to 100 centimeters. And if you cancel, you see that only one of those meters has gone away. So we're going to have to do that same thing 2 more times. So 100 centimeters over 1 meter. And then one more time, 100 centimeters over 1 meter. Those cancel. Those cancel. And so now we've gotten units of centimeters cubed. We have 3 centimeters there multiplied together. And the number is 100 times 100 times 100, which is 1,000,000. So it takes 1,000,000 of those little centimeter cubes to fill a cubic meter box. Any questions about that?